maximum product of two elements in an array. Here's the narration. You're given an array of numbers and you need to pick two of them at different positions. For each of the two numbers you pick, subtract one from it, then multiply the two results together. Your goal is to choose the two numbers that make this product as large as possible and return that largest value. Intermediate level, 500 numbers, but only two decide the answer. Find the two biggest and you're done. Everything else is noise you're allowed to ignore. By the end, you'll spot this. Only the top two matters pattern in seconds. This shows up as an early screening question at places like Amazon and Adobe. It's a trap for people who instantly reach for nested loops. The same grab the top few's idea powers, leaderboards, and top K ranking everywhere. You choose two different positions in the array, you subtract one from each value, multiply them, and you want the largest possible result. So for 3, 4, 5, 2, the best pick is 4 and 5. Forget code for a second. Picture a race photo. To hand out gold and silver, you scan for first and second place. The runner who finished 9 changes nothing. That's this whole problem. The array is the photo, and we only ever want the top two on the podium. Here's the trick. Since we subtract one from both and multiply, bigger inputs always give a bigger result. So the two largest numbers must win. Nothing smaller can beat them. In short, find the top two and stop thinking. Let's name this the top two grab. We walk through the array once, holding on to just the biggest and the second biggest we've seen. That's the whole strategy, and it never needs more than two variables. Simplest thing that works. Sort the array, then the two largest are sitting at the very end. We grab those last two, subtract one from each, multiply. Clean. After sorting, the array runs smallest on the left to largest on the right. So the last box holds the biggest number and the one before it holds the runner-up. That's why we read from the back with negative indexes. Instead of sorting, we walk through ones holding the top two. If a new number beats our champion, it becomes first and the old champ slides down to second. This does in one pass what sorting does in more work. Notice what happens when a bigger number arrives. It can't just erase the old champion, because that champion might still be our second best. So we shift it down into second. That one line is why we never lose the runner-up. Quick challenge. Freeze the frame. Two twos come in. What does our function return? Think it through before I show you. It returns 1. Different indices are allowed even when the values match, so both twos are fair game. 2 minus 1 times 2 minus 1 is 1. This is exactly why the problem said different indices, not different values. I'll admit it, the first time I wrongly forced two distinct values and my answer broke on duplicates. You could just try every possible pair and keep the best product. Plus side, it's dead obvious and hard to get wrong. Minus side, it checks roughly n squared pairs, which is wasteful when we already know only the top two matter. Brute force is big O of n squared time. Sorting drops that to n log n. The top two grab is big O of n time and constant space. And there's the pattern paying off. In short, for this problem, always reach for the single pass. Duplicates are handled since we track positions, not distinct values. The array is guaranteed at least two elements, so first and second always fill. And all ones give 0, because 1 minus 1 is 0, no crash. Just a correct boring answer. Remember the trap from the start. 500 numbers that look scary, only 2 ever mattered. The top 2 grab find them in one pass, and now you'll see the same top few shape in leaderboard and ranking problems everywhere. New daily drops tomorrow, same time, when this exact trick cracks a harder heap problem. See you next time. If you're not subscribed yet,